Alright, why is the Amazon dying? This is a question that's been asked for about 40 years now. It has to do with something called combustion. Combustion is the ignition of fuel with oxygenated air, or in some cases, even pure oxygen. That is a simple definition that powers almost 80% of factories, almost all aeroplanes, most cars, and all cruise ships and small boats. Now, this is the equation for a normal combustion reaction. It takes 2 moles of octane plus 25 moles of oxygen, and then through an exothermic reaction, it turns it into 16 moles of CO2 and 18 moles of H2O. Now, most people point to photosynthesis as a solution for absorbing all of the carbon dioxide that's left. However, photosynthesis can do only so much, where a car engine or a combustion engine in general puts out 16 moles of carbon dioxide. Photosynthesis puts out or takes in 6 moles of CO2 and 6 moles of H2O, and then through endothermic processes turns it into glucose and oxygen. However, both of these equations have something in common. Yes, this word, gigantic word I know, equilibrium. Both of these equations have their own natural equilibriums. However, if this gets too out of hand, meaning if we use up too much fuel, then the natural equilibrium will shift towards the product side and shift towards carbon dioxide. Then, if we use less carbon dioxide though, it'll shift toward the side without carbon dioxide. More specifically, the side with actual oxygen and oxygenated air. Same here. If we use more CO2, that'll actually, or if the plants absorb more CO2, that'll increase the amount of oxygen because the laws of Lacheys Principle says that increasing the reactants can increase the product and it'll find its own natural equilibrium. Now, scientists working on this for the better part of 40 years have been saying the same thing over and over and over, which is reducing the hydrocarbon usage will reduce the CO2 output and CO2 emissions. And again, as I said, this shifts the theoretical equilibrium towards non-carbon dioxide, right? Basically, oxygen in the combustion reaction and increasing oxygen in the photosynthesis reaction. Now, scientists are working to reduce the dependency on fossil fuels. However, if we don't plant more trees, it won't really matter though, but I'll get back to that in a little bit. Reducing the temperature of photosynthesis follows another part of Lacheys Principle, which is that reducing the temperature will also mean that the equilibrium in photosynthesis is shifted away from CO2 because it favors an exothermic reaction. But unless we plant more trees and also increase sustainable energies, the temperature and equilibrium will do precisely the opposite and we'll be in serious trouble. So, what are the other options? Well, there's nuclear energy, which is a little bit. It's very, very nice because in the 1950s we were thinking about it, but now we know the dangers of nuclear fuels, such as even after depletion, nuclear fuel is highly radioactive. When in use, it's even more dangerous because it is highly unstable because it uses uranium or plutonium. And if it gets out of hand, well, you have Chernobyl. So you have Chernobyl or Fukushima because that's just what happens. If a reactor goes out of control, then radiation is potentially dangerous and could kill people. Then you have solar power. Solar power isn't really as dangerous as nuclear fuel, but solar power is very inefficient. Right now, the highest a solar panel has ever gotten out of efficiency is about 42%. That's experimentation. However, in practice, usually these solar panels get about 15 or 20%, meaning that they have a 20% conversion rate between photovoltaic or photoelectric energy into actual usable electricity. Plus, solar panels can be covered with dust, so you can't always rely on them. Same here with wind, because wind relies on wind, and if there isn't any, then no more wind. And 40 to 50%, again, that's an experimental number. So, unless we develop all these technologies to make it less dangerous and more efficient, then we can't really do anything. So, what should we do? Luckily, there is another alternative. Trees take in 48 pounds of carbon dioxide every year. That is per tree. Now, the Amazon rainforest has 390 billion trees and makes up 17% of the world's carbon reservoir. And this is where I said I would get back into photosynthesis, because 48 pounds of carbon dioxide per one tree times about 390 billion equals this much CO2, 18.7 trillion pounds of CO2. Now that times 0.84, because 16% of the rainforest has been chopped down, that reduces it to about 15 trillion pounds, which is a net of 1.5 billion tons lost through the chopping down of trees and deforestation in the Amazon. Now, what can we do to help this situation? Happily, even YouTubers are starting to take effect. Team Trees, which was a hashtag that was going around last year, was an initiative to plant 20 million trees around the globe. However, the rather disappointing news is it really absorbs 500,000 tons of carbon dioxide, which still pales in comparison. It's still bigger than a cruise ship or a container ship, but it still pales in comparison to the magnificence of the Amazon. So, we'll have to plant at least 3,000 times more trees, which equates to about this many. Yeah, we have to replace 62.4 billion trees that we, humans, chop down in the Amazon. So we should never ever mess with nature. So in future, if we actually manage to do this, we can all teach future generations, do not mess with nature or it'll mess with you. Thank you.